I'm John, one of the electromechanical instructors, and we're going to go over the numbering systems, binary, hex, octal, and BCD, counting from 0 to 15. You don't really have to memorize the placeholders. You don't have to memorize the conversions. By understanding a little bit about those numbering systems, that I'm sure the book has more than enough information, we can count from 0 to 15 without memorizing anything. So we're going to use 4 digits for our binary, and of course engineers start counting from 0, and 1 is just a 1 in the ones place. Remember, our binary is the ones place, the twos place, the fours place, the eights place. So a 2 is simply a 1 in the twos place. A 3 is a 2 plus a 1 for 3. A 4 is a 1 in the fours place. A 5 is a 4 and a 1. A 6 is a 4 and a 2. A 7 is a 4, a 2, and a 1. An 8 is a 1 in the eights place. A 9 is an 8 plus a 1. A 10 is an 8 plus a 2. An 11 is an 8 plus a 2 plus a 1. A 12 is an 8 and a 4. Had to use my fingers there for a second. Don't be afraid to use your fingers. 15, we might need to get to toes, but we'll worry about that later. 13 is an 8 and a 4 and a 1. A 14 is an 8 and a 4 and a 2. And a 15 is an 8, 4, 2, and 1. And the 15 being all 4 bits are a 1. That's important to remember. I am going to use some highlighting software here. My columns aren't exactly lined up, but if I look at the ones place, I have a 1 and a 0 and a 1 and a 0 and a 1 and a 0. We skip every other place. Now, if I go to the twos place, I have 2 zeros and 2 ones, 2 zeros and 2 ones, 2 zeros and 2 zeros. These aren't quite lined up, and 2 ones. And you're getting, I think you're getting the idea. I'll go to the fours place, and I have 4 zeros and 4 ones, 4 zeros and 4 ones. And if I go to the eights place, I have 8 zeros and 8 ones. So rather than memorizing the values for each number, just remember the pattern. The ones place is 0 and 1, 0 and 1. The twos place is 2 zeros, 2 ones, 2 zeros, 2 ones. Fours place, 4 zeros, 4 ones. And just by using that, you can count from 0 to 15 in binary without a lot of struggle. BCD stands for binary coded decimal. So BCD, the thing to remember is that the B stands for binary. The main thing to remember about BCD is the B is binary, so the numbers are the same. Until you get to 9. 9 is fine. However, for 10, we can do two things. We can call it invalid. So you could just, there is no BCD equivalent for 10 because decimal means by definition 0 through 9. So after 9, our BCD equivalent would be a 1 and then a 0. And for 11, would be a binary 1 and a 1, binary 1 and a 2, and so on. Understanding that 0 through 9 is binary will help you if you need to use BCD in the field. Hex stands for hexadecimal, and hexadecimal needs to represent 0 through 15 with only one character. Well, once we get past 10, we've got two characters. Similar type of problem with the BCD. So for hexadecimal, zero through 9 is fine. Once we hit 10, well, the engineers just said, well, let's use letters. A, B, C, D, E, and F. So F is 15. Binary 1, 1, 1, 1 is 15. By knowing these three values is very useful in programming because it means all bits are high. Octal is base 8. Binary is base 2. Well, there's no 2. There's only a 0 and 1. Octal is base 8. That means there's going to be no 8. So from 0 to 7, our numbers are in heaven. I know, it's corny, it's cheesy, but it works. After 7, well, we don't need any strange characters. We just go to 1, 0. Octal is used in PLC addressing because words are made up of bytes, and bytes have 8 bits. So 0 through 7, and then our next set of bytes of data, those words of data are numbered 10 through 17. Hopefully this chart will help you. You're welcome to print the chart, fill it in when you're doing your quizzes or assignments. Understanding these numbering systems from 0 to 15 is going to be very, very, very helpful to you on the job. Even if you're not writing programs, just reading them, you'll be able to understand what the data is doing and be a better technician. Thank you.